All right, here we have an example from chapter 17, which is focused on oligopolies. And here we have a duopoly. These are two firms that are trying to make strategic decisions. And the reason why it's nice to look at two firms is because they're the only two firms in the market. And so what the choice of one firm can have a huge impact on the choice of the other. And so when they make their decisions to operate their businesses, oftentimes it's going to be this coordinated game, which is what we think of as game theory. And so these companies, we have company A and company B. Those are our players in this game. And each company has two strategies. They can advertise or not advertise. And based on their strategies that they choose at the exact same time, we'll see different payoffs for that. So if company A chooses not to advertise and company B chooses not to advertise, company A, which is the player on the left, will get $10 million. Company B, is the player on the right, will get $20 million. If company A chooses to not advertise and company B chooses to advertise, then company A will get $4 million and company B will get $30 million. And vice versa. Each of these squares is a payoff. And so we think of this as a matrix. All right, so some type of table that shows us the different strategies and different payoffs. So what we want to be able to do is first determine the Nash equilibrium of the following game, and then explain if that game has the characteristics of a prisoner's dilemma. So first, to find the Nash equilibrium, what we want to do is we want to be able to set one player's actions as fixed, and then determine what's the best response of the other player. So first, let's look at player B. Let's assume that player B is going to not advertise. What is the best strategy of player A, or company A? Well, if company A doesn't advertise, they'll get $10 million. If they do advertise, they get $20 million. So we're comparing these numbers. We're not looking at these because company B has already chosen not to advertise. And so in that case, company A is better off by advertising. Now let's assume that company B is going to advertise. Okay, so company B is fixed or set in their strategy. Now company A has to choose, do we not advertise or advertise? If they don't advertise, they'll make $4 million. If they do advertise, they'll make $5 million. So we're comparing these numbers for A, therefore A will choose to advertise. So when we think of company A, regardless of what company B is going to do, company A will always advertise. So we call that a dominant strategy. So whatever it is that B does, A is always better off by advertising. Now let's look to see what B should do given A's actions. So let's assume that company A does not decide to advertise, says don't advertise. Well, company B can choose between advertise or don't advertise and get $20 million, or advertise and get $30 million. B's company is comparing left to right. A compares up and down. So in this case, B will want to advertise. Now let's assume that company A is not going to, or is going to advertise. Company B chooses between don't advertise and $12 million or advertise and 15. They'd be better off to advertise at 15. And when you notice that company B is always better off by choosing to advertise. And that is their dominant strategy. Now the question is, where's the Nash equilibrium? Well, a Nash equilibrium is defined as given the outcome, there's no incentive for a firm to deviate. Well, here we have our two check marks, so that actually identifies our Nash equilibrium. So our Nash equilibrium, we'll write it NE, is advertise. We put player A's strategy first, comma, then player B's strategy, advertise. Both firms choose to advertise. And that's our Nash equilibrium. Now let's just check that to make sure. So let's suppose they both decide to advertise. Company B says, well, actually, I'm not going to advertise. Well, they're going to go from $15 million to $12 million. So they don't have that incentive. Let's suppose that company A says, well, I don't want to advertise. They're going to go from $5 million down to $4 million. So they don't have an incentive. So that there is our Nash equilibrium. And if we solve it using the check marks, that's how we find the Nash equilibrium. Now the question we want to ask next is if this game is a prisoner's dilemma. The characteristic of a prisoner's dilemma is that if both players cooperate, they can come out with a better outcome than if they act in their own self-interest. Well, let's suppose that both players decide to cooperate and say, let's not advertise. If that's the case, then this would be the cooperation strategy. Is that firm A would get 10 million, company B would get 20 million, which is better for both of them than the Nash equilibrium. So let's suppose they say, let's cooperate. Well, if they're going to cooperate and agree to that, what should company A do? Well, if they think that company B is going to advertise, company A can deviate and advertise and get $20 million as opposed to 10. So they have an incentive to cheat the deal and to advertise. If company B looks to say, assumes that company A is not going to advertise, then they're choosing between if they advertise 30 million as opposed to 20. So they'll deviate as well. And in fact, both companies will deviate and will end up at our Nash equilibrium. And this outcome makes both players worse off. So this is a prisoner's, I'm not going to spell this right, dilemma. Okay, here's how you actually spell it. But that's going to be a prisoner's dilemma game.